Hello, everyone, and welcome to our webinar, AI-powered personalized shopping and recommendation engines. My name is Matt Brown, and I will be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars. We do 2 per week, demoing data and AI use cases, new tools, and new technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, please feel free to connect with me on LinkedIn to stay in the loop. I also love to hear your feedback or any ideas on future sessions that you'd like to see. Speaking of future sessions, if you click to the next slide, you'll see that we have several great new webinars coming up in the next few days. So tomorrow, the 11th, we're going to be doing build vector embeddings for video via Python notebook. Akmal here, who's on screen, you've probably seen him before at our past webinars. He's going to be presenting that webinar tomorrow, helping with our Q&A, audience Q&A today, but he will be the main event tomorrow. So hopefully we'll see you there. And then Monday, we are presenting fine-tuning your embedding models with SingleStore. And then on Tuesday, the 16th, we are going to be presenting Apache Spark plus OpenAI for personalized banking services. So I'm going to put all of these short links in the chat in just a few minutes. You could also take photos of those QR codes if you would just want to jump straight to the RSVP landing page. But I'll put that link so you can just click it directly in the chat in just a few minutes. Hopefully you'll register and we can see you at some of those future sessions. Also, we're looking into FYI, we've gotten some questions on just auto registering for these upcoming webinars. If that's interesting to you, let me know. We're working on the functionality to try to build that in so that you can do that automatically. Right now, it's not in place yet, but if that's something you're interested, let me know, and we'll keep working on it for you. Back to today's topic, we would love for you to participate in the discussion throughout the session. There's a button at the bottom of your Zoom console. It says Q&A. That's the one that you should use. The chat does not work during these sessions, but you can use the Zoom Q&A. We have a mission statement to try to answer 100% of the questions that come in, even though we have hundreds of live attendees that come in during these sessions. Just make sure that you include your name and email address. You might have to log out and log back in if you logged in anonymously, because we only answer non-anonymous questions. So we look forward to hearing what you have to ask about. We'd also love for you to actually try the technology that we're going to be showing today. In fact, anyone who tries it today will be entered for a chance to win either new AirPods Pros or Meta's new Ray-Ban LLM smart glasses. It's your choice. If you are the winner, you can get either or. Very easy to participate. We're going to put this link in the chat. Just log in. It's that short link, AI personalized shopping. I think that's it. Let me make sure that is it. Yes, that's it. If you log into that link, if you already have a SingleStore account, just log in. If you don't have an account yet, we have a free shared tier. Very easy to use that free tier. You just log in, sign up in a few seconds, and you can be eligible as well. So I will announce our winner at the end of today's session, and you can choose your prize. Let me introduce our speaker. Ingrid is a cloud solutions engineer at SingleStore. She has been with us for 6 months now. She's already found creative ways of leveraging our Gen AI capabilities to create modern applications. One of them is this fashion recommendation engine that she presented during our company kickoff a few days ago. It got a lot of buzz around SingleStore. People were really blown away by it, thought it was awesome. So by popular demand, she's going to be sharing it with you all today. Hopefully you can build one of your own. Awesome. Welcome to our audience. Welcome to Ingrid. The floor is now yours.
Thanks, Matt. So hi, everyone. Like Matt said, my name is Ingrid, and I am one of the solution engineers here at SingleStore. And yeah, I'm super excited to share with you all today how to build an AI-powered fashion recommendation engine. So just to set up the scene a little bit and tell you a little bit, why I thought it would be relevant to build this thing out. So I am from the Bay Area, and I'm very grateful for that because I don't need to put in too much effort into thinking what to wear, which is great because my sense of fashion doesn't really go much beyond athleisure and gym clothes. But if I were to live somewhere else, I would definitely need some help, uh, to get some outfit inspirations. So something like a wardrobe assistance would be great. But of course, I can't really afford a personalized shopper, nor can I probably afford to buy the things that they would recommend me. So I got this idea, what if there's an app that allows me to upload a photo of an outfit, maybe something that I saw on Instagram, but that didn't have a tag, or something that I saw on a friend at a party, but was too shy to ask where they got it from. I can then just upload this photo to the app and instantly get recommendations of similar products that are available to buy. Even better if I can set a price filter, just in case that friend at the party has a different budget than me. So this is exactly what we'll be building today. And let me actually just show you the demo itself. Just a little sneak peek. Okay, so this is a web app. We are going to be building this out from scratch today. But if you go to this link, you can actually access it right now. So let's go ahead and just run a little test. And I will be going over, exactly what the app is doing in the background. What is this query doing? What is hybrid search? As we walk through the process. But for now, just want to show you that it kind of works. So let's say I want to see, what kinds of purses similar to this one that my friend has are available there for me to purchase. So I upload this photo in this app and I can get the top most similar results that are out there. And of course, in this case, I can also set a price, a max price. All right, so that's it for the sneak peek. But before actually diving into the working session, just want to take a step back and zoom out a little bit. So a lot of you guys might be familiar with this already, but really just want to get everyone on the same page and talk about the AI stack architecture for a little bit. So really, the AI architecture boils down to 3 layers. You have the UI layer on top. That's the way you interact with these AI models. The next layer is the API layer that actually hooks up the LLMs, the databases, to the UI. And then finally, you have the contextual data store. And we here at SingleStore, we believe that your data should not be fragmented and stored into different databases. So if you're using Pinecone as your vector store, for example, you would still need to store your non-vector data in somewhere like MongoDB. And maybe you're also using Snowflake as a data warehouse. And then to tie it all together, you need to do some ETL. So the problem with this fragmentation of data is that it can add to the latency, which is critical when we're talking about real-time AI applications. For example, you might not want to talk to ChatGPT if you need to wait a minute for an answer every time. And then the second issue is this data integrity. So the more copies of your data you're storing across different databases, the more error-prone or less accurate your data can get. And finally, of course, it can get expensive to keep up with all those databases as well as managing them. And so that's where SingleStore comes in. And we simplify your database layer by being the single source for all of your data needs. And when it comes to AI specifically, we let you store vectors, but also your traditional data types. So essentially a relational database combined with a vector store. And I'll dive into the benefits of this later as we are building out our application. So double clicking on this contextual data layer for a second. What do we need to do exactly? Well, first of all, your contextual data layer needs to store both structured and unstructured data. So like PDFs, videos, images, and we have to be able to translate between those different modalities. So for example, we would have to find a way to extract meaning from images, which we will be working with today. And this is where we can leverage LLMs to do vectorization of this data in order to interpret and to work with them. So when we vectorize our data, we are essentially processing the unstructured data into a format that is easily searched over. And then we can do things like similarity search once all the data is in this vector format. And today we will be using one of those multimodal embeddings or vectorization model where we're leveraging OpenClip from OpenAI, which is an embedding model that was pre-trained on a massive data set of images. And in particular, we will be using a variant of this embedding model that was built on top of OpenClip, but was pre-trained on a large data set of fashion items specifically, and is called Fashion Clip. Okay, so the last topic I want to touch on before we dive into the working session is just to make sure everyone knows who SingleStore is and what we do. So SingleStore was actually founded as MemSQL 13 years ago. Some of you may know that name. And we started off with really just being an in-memory database. And we were awarded a patent for our universal storage table type that combines row store with column store and lets you do both transactional workload as well as analytical workload. And then in 2017, we added vector support. So we were really ahead of the curve at the time, as opposed to some other databases that have jumped on the AI bandwagon and added vector support in the last 12 months. Our vector solution is fully integrated into the rest of the ecosystem. So it's not a bolt-on solution. And it's something that we've kept improving on for the last 7 years. And this year specifically, we had a milestone release, the Pro Max release, with a bunch of new vector capabilities, such as advanced indexing that allow you to do things like ANN or approximate nearest neighbor search in SingleStore, which puts us on par with the leading specialized vector databases in the industry. So yeah, in 2020, we rebranded as SingleStore because we were no longer just an in-memory database. And our mission was to become truly the single destination for all of your data needs, to simplify your architecture and bringing real-time to your applications. We've surpassed $100 million in ARR, acquired more than 350 customers ranging from unicorns to the largest banks in America and other Fortune 50 companies. But we are also becoming very friendly to individuals and small teams, as you've seen with the launch of our free tier or shared tier, which we'll also be using in just a bit. All right, so what is SingleStore in a nutshell? It is a data platform that allows you to transact, analyze, and contextualize data in real time. And just breaking it down a little bit, from a transaction perspective, we have, like I just said, an in-memory row store that lets you do the extremely fast writes and record lookups. So we power a lot of operational applications that require this super fast stream ingestion using our built-in pipelines, which we'll also be using today. And because we are a distributed database, we can scale those low latency and high concurrency support by just adding more nodes. And then from an analyze perspective, we give you the ability to analyze data in real time thanks to our column store, which lets you do sub-second aggregate functions across millions of rows, and that is across different data types as well. And then, for instance, SingleStore can deal with JSON data in terms of understanding and actually processing it extremely well, as opposed to some other solutions that might only be able to just store it as a block. And then the final piece, contextualization, and this is really all about our built-in vector support that we are focusing on in this webinar. So as we're about to see, SingleStore doesn't just let you store vectors, but we have built extensive functions to let you work with those vectors and combine vector search with traditional filtering and joining, meaning that you can join your vector data onto all of your enterprise data and do more personalized matches. And we call that hybrid search. So in summary, why SingleStore exists when there are hundreds of other databases out there is that we are truly a unified solution for all of our data needs. Not only do we enable you to do high performance operational and analytical workload, and this can be done at a very large scale, but we also combine all of that seamlessly with the vector capabilities, which means that in other cases, you might need 3 databases. You can do all of that with just SingleStore. Okay, so I promise almost done with this theory section, but this slide just shows you how our 3-tier architecture works. So first, when the data lands into SingleStore, it will hit the memory layer first, land into our row store, and then it gets immediately committed and flushed to disk, and it lands in our on-disk column store. And because it's on disk, we can compress this data by on average 75%. So you're saving 75% of your cost as well. And then the final step is that this data actually gets persisted into our cloud object store. So this gives us what we call unlimited storage, where you can have as much data as you want, and you're uncoupling storage from compute. So this is our 3-tier architecture, memory, disk, and cloud storage, and these combine to make up what we call universal storage, which is our patented table type. And then lastly, we are fully distributed, as I said. So we have leaf nodes and aggregator nodes, and both can be scaled out depending on how much concurrency, what's the latency that you need. So of course, SingleStore is an HTAP database that lets you do both transactions and analytics super fast. And that's been our bread and butter for years now. But since we're focusing on AI and vectors today, let's just do a quick recap of why we believe that SingleStore is the best database for building Gen AI applications as well. So you can use all the data relevant to your company, not just your vector data. We have multimodal support, so can really support any type of data that you have. We have pipelines that enable you to ingest millions of records per second. And we also have a built-in Jupyter notebook that we will see in just a bit that lets you run both Python and SQL. Sounds good? Now let's finally see SingleStore in action. Okay, so yeah, if you remember from 10 minutes ago, I was saying how I wanted to build this app that let me upload a photo of an outfit and then specify a price and maybe some must-have keywords, and then get recommendations of similar products that are available to buy. So I built this app, and full disclosure, I asked ChatGPT to give it a name, and it came up with Style Snatcher. So that's the name that I am sticking with. But behind the scene, Style Snatcher leverages SingleStore's hybrid search ability that we talked about earlier. to do a similarity search, to do a similarity match combined with full text search that allows you to specify keywords, as well as metadata filtering that allows you to filter on the price. And as for the setup, I started off with a Kaggle dataset that contained over 100,000 records of fashion listings from Farfetch, which is a luxury e-commerce company. And then each record has the product's brand, description, price, and image. And then I turned those images into vector embeddings using an embedding model, Fashion Clip, that I mentioned earlier, which is this model based out of OpenClip, but fine-tuned for the fashion domain. So yeah, so once I got my vector embeddings for the images, I then stored them into my SingleStore database as a vector data type alongside the other product information. So remember that SingleStore has this unique ability to handle both vector types alongside your traditional data types, which is what allows us to do hybrid search. And then lastly, the application framework I used was Streamlit, which essentially turned my Python script into a web app. So just a quick note on Streamlit, it is an application framework that essentially lets you build web apps for machine learning and GenAI projects very easily. So no front-end skills required, which is great. You can just write your backend in Python, and there's some functions for the UI that you can leverage. It's also very data science friendly. It supports all the libraries and visualizations. And it also integrates with GitHub code spaces, which means that you no longer need to build your development environment. And we will also be using CodeSpace today. And lastly, it makes deployment a breeze. So it has its own hosting solution, Streamlit Sharing. So once you're done building out the app, you just push it to GitHub, and then it automatically generates a link hosted on Streamlit for you. So no more Docker or EC2 struggles. All right. Finally, we're at the portion of the webinar where we are going to do some coding and see how everything comes together. Okay, so first thing that you want to do, I have too many tabs here. Also, by the way, all the code that you need is in this GitHub repo that I believe maybe we have already sent out. So you can also follow along. All right, so first thing we want to do is to sign up for a Streamlit account. So just click sign up now. And then once you do that, click on sign in, and it'll take you to this page. So I already have an app, Style Snatcher, that I was showing you guys earlier. Okay, I need to reboot my app because I made some changes earlier. So I already have one app running, but I will go ahead and create a second one from scratch along with you guys. So click on new app, and then you're gonna select create new app with GitHub Codespaces. So you can give it a name. I'm gonna call it New Style Snatcher. And it's going to take a few minutes. It's going to take a few minutes to create the environment. And that's why I wanted to do that first. So it created the code space. Now code space is building the container. And yeah, it will take a few minutes, but maybe it's also because I have really bad Wi-Fi here. So I will hop over to the SingleStore side of things. And oh, I think we have a question.
Ingrid, whilst you're kind of just waiting for that, could you just share the link to the GitHub repo again, please? And I think there was a question. You showed briefly the app itself running, which is, I think, the Streamlit hosted app. Could you share
Yeah,
that link as well? And then Matt will be able to send that out to everyone. That would be
yeah,
really,
I
really
just
helpful.
posted the GitHub link, but
Oh,
I don't have the
awesome.
other one.
Yeah, great.
yeah. The other one is you can also access it from the README page, but I'll share it right here. Once it's done rebooting.
Right.
Yeah, thanks for that.
Great, thank you.
Of course. Cool. So while we're waiting for, oh, it's already done, but I also just wanted to make sure that everyone has a SingleStore account because we will be using that to, store all of our data. So head over to singlestore.com/cloud trial if you haven't spin up a trial yet. And once you log into your portal, you're going to see a page like this. And then you want to create a workspace. So click on group on the left sidebar. And then you have two options. So you can either create a starter workspace, which is free forever, but there are some limitations around the number of databases that you can have and the amount of data you can store. Or you can choose to create a premium workspace and you will have $600 of free credits, which is way more than enough to let you build this app. But yes, even if you choose a starter workspace, you can build and you can store the vectors and run the app that we are building out today. Okay, so once you're done setting up a workspace, remember how the first thing that I did after I got the data was to create embeddings from the image columns. So we will be using SingleStore Notebook to do that. And once you head over to my GitHub repo page, you're going to see there's a SingleStore embed dataset notebook template. So you can download the template from there and simply import it in SingleStore. And how are you going to do that is by going to the develop section. And you will see that we have this new notebook button. So this is really neat because you can actually import an existing notebook template. So in this case, once you download that SingleStore embed dataset, you can just click import and it will appear in your environment. But I have already uploaded before. So while it's taking some time to load, let me just show you another way that you can do this. If for some reason you don't want to run this script in the SingleStore notebook, you can totally just run it in your own IDE, in your own Python environment as well. So I also provided the script over here, embed dataset. So yeah, two scripts. This one is just a Python script. You can run it outside of our notebook environment. And then the SingleStore, S2 for SingleStore, embed dataset. This is a notebook that you can run in your portal. So just to show you what we are doing here, first, you need to select your workspace and the database that you just created. So for example, if you created a starter workspace, make sure that you select that in the dropdown. So of course, first thing, we want to create a table to store all the information related to our products. So I'm storing the brand name, gender, the image URL, and by the way, each product has 2 images, as well as the price, description, and then I'm adding a sort key on the price to speed up the filtering, as well as a full text index on the description, because we will be doing a full text scan if the user mentioned some optional keywords. So I won't run through these because I have already generated the embeddings, but you can run each cell by clicking the play button or command return. All right, so step 2 is we want to ingest data from S3 bucket. So what I did was I downloaded the Farfetch dataset from Kaggle. I then uploaded to a public S3 bucket, so you don't need credentials to access it. And we are pointing the pipeline to our source table that we have just created. So once you run that, once you start the pipeline, it should be pulling the data into your table. And then you can see some summary info by running this command and see some simple data set. And okay, the third step is to actually use Fashion Clip to embed your images. So here I'm just defining a function to encode both images. And then once that is done, we want to just iterate over our data set and create embeddings for both the model image as well as the cutout image. So this will take you around 20 minutes to run. That's why I'm not doing it here. I have already embedded all the images. And the last thing that you want to do once you're done that is to alter your table and add 2 vector columns. So the model embedding and cutout embedding. And you want to join those 2 new columns onto your Farfetch listings table in SingleStore. So yeah, this is the first way of doing the initial embedding. You can also just take the Python script and run through that. Then you don't have to like run every single cell. All right. So I will just show you what the final data look like. So once you're done that, you should see something that looks like this. You have those columns. And if we look at some sample data, you can see we have the image URL. So all of those are what was there in the original data set. And then you have the 2 new columns that we generated from Fashion Clip. Okay, great. So now let's actually begin coding and build out the app. So once you have your new Streamlit app, first thing that you want to do is to install some dependencies or requirements. So you already have requirements.txt, and you want to replace those with these libraries. And yeah, you can find all of this in the repo. And we want to do a pip install requirements. So this is going to take some time because Fashion Clip is quite a big library. So let's go back to our main file, which is hello.py. Yeah, and if you've never worked with GitHub Codespace before, I really like it. I just found out about it like a month ago, and it renders this UI in your browser, so you don't need to like deploy any development environment. You can just click. It's going to show up later, but there's like a rerun button. So every time you change something in your code, it will reflect directly. Okay, so let's remove everything that is in your hello.py. And we are going to start off by first importing all the dependencies that we just installed. And then we will, so you can just copy the code directly from this stringlet app.py file. I just have a few more, like I have more CSS and UI stuff there, but we will be keeping it pretty bare bone today. I'll just show you the essentials. So you will see a little, you will see some lines that I am skipping here. So Streamlit has all of those, everything ST that you see is a Streamlit function. So remember how I said with Streamlit, you don't need to have any front-end skills. So all you need to do is to use those Streamlit functions like sc.write, sc.slider if you want a slider, file uploader, and once I hit save, you will see them appear here. I'm just waiting for all my dependencies to install first in order to import Fashion Clip. So what we're doing here is just, we are setting up a price slider, a text box for optional keywords, a file uploader, and then also a select box for the number of results. And I'm giving the user the option of selecting either 3 results or 6. And that's just because I can like separate them out into 2 rows and it makes it pretty. All right. So my requirement.txt.text was installed, and now I can see if my hello.py can be run. So you see it says source file change. We're going to hit rerun. And just pray that it works. Okay, great. So yeah, we can see the slider, the keyword, choose an image, number of results. But now if you hit find matches, it's not going to do anything because we need to connect this application to SingleStore. So next thing, we want to define a function that takes in the image that the user uploads and create embeddings with the same Fashion Clip model. So we're gonna have this define. This sidebar is really annoying. I feel like my screen is too small. Okay. So we're gonna have this generate embedding function that takes in an image path and just encode this image. And then we're going to have another function that finds the top matches. That compares basically this query image to the embeddings that we have in our database that I was just showing you here, and find the top matches for that input image. So let's break it down. We are connecting, so we're opening up a connection to SingleStore, and then we are sending this query to SingleStore. So what is it doing exactly? It's selecting the brand name, the image, the image cutout URL, the description of the product, the price, and then we're doing a dot product between the query embedding and the embedding stored in our embedding column in our table. And we're selecting the top, whatever, like 3 or 6 similar matches. And yeah, ordering by similarity score in descending order because like 1 would be perfect match. And then notice how here I have an if statement. So because I want the keyword to be optional, if a user specifies a keyword like a purse, or the description has to contain that word, then I am doing a full text search where I am taking the keyword that they specify and doing a matching against short description. So if they are not specifying a keyword, then I'm simply doing a dot product without that full text search. And then the last filtering I'm doing is on the price. So specify the max price, and I have that in my where clause as well. So that's for the function find top matches. And now we need to tie everything together. All right, so a simple function to initialize the connection to SingleStore. And by the way, there will be a place to input your secrets, your SingleStore secrets. So that is your workspace URL, your database name, and all of that. I will show you guys in just a bit where to add that info. But for now, the main logic is if the user hits the submit button and uploaded a file, then we will create a temporary file in order to grab the path of the file, because the generate embedding function can only take in a file path. For initializing the connection to SingleStore, we're calling find top matches with the price, keyword, and number of results that they select. And then all of this is just to render the resulting images based on, like, if there are 6 results, then we want to separate them out onto 2 rows. So, oh, okay, that just looked a little bit weird. So that is really everything that this application is doing in order to run. As I said before, my app here, I think I have some Wi-Fi issue. Let me try rebooting again. Well, okay. Hopefully this works, but I've never seen that before. And of course, it always happens when we're doing a live demo. But I was saying that in my original app, I had more like CSS and backgrounds and sidebar and all of that. So there's some extra code that you'll be seeing in my Streamlit app.py here. But really, if you just follow everything that I wrote here, you should have a functional app. All right, so now let's test it out. Before committing to a new GitHub repo, I just want to delete some extra stuff that Streamlit generated for me. So I'm going to delete this pages folder, as well as this dev container. Okay, make sure that I save this. Git status. Okay. So I want to add all of my files. initial commit, and then do a git push. Cool. So now if I go back to my Streamlit tab, I should see that I have a new app here, new style snatcher. Great. So notice how it's still reflecting the old template. So I need to do a reboot from the setting page. And while I was doing that, I will show you where to put your single source secrets. So click on the three dots again, go to settings, and you can find the secrets tab. And this is where Streamlit will take all of your environment variables. And in this case, our environment variables are the following. So first you need the SingleStore workspace host URL. And then you need the port, and by default, single source port is 3306. Your database's name, and then user and password. So in case you can find those information, I will just quickly show you where exactly to get all of this. So go back to your SingleStore portal, click on the workspace that you are, let me just start with a new workspace. Let's say your workspace is called Starter Workspace 4. So in order to get all of that connection information, click on Connect. And then you can click CLI client or whichever, it doesn't really matter. And then you can see that you have a username here, a password that you can configure. And then once you click on create user, you can see that your host URL starts with SPC and it ends with singlestore.com. So this is the URL that you want to copy over to your secrets tab. I'm going to save it. Yes, Ekmal, you have someone.
Yeah, Ingrid just wanted to, I think there's a question or two about this. So for the free tier, I think that the details that you just showed, it's actually port 3333. For the one that you normally create with the $600 credits, yes, it's 3306. And the other thing worth noting is that with the free shared tier, you actually need a PEM file as well. Because in order to access, because you are using a shared environment, and therefore it won't give you direct access to that. So the port number is important, the PEM file is important. But other than that, I mean, it's a great way to get started quickly.
Okay, yeah, that's yeah, thanks for that, Akmal. So note that everyone, you need a PEM file, and it's 3333 instead of 3306 if you use the shared tier. Okay, so I think our app is still baking in the oven, and I know we have 10 minutes. I'm sure it's going to be done before then. Oh, okay. I think something is coming up. I was just going to use this time to go back to our presentation and maybe mention some of the next steps or additional resources. If Matt or Ekmel, you want to take this while our app is finalizing the baking process?
Yeah, you also have some questions that are still outstanding. I know Akmal has been very busy answering, but I see a couple in here. One here is from Monica. Can you explain how you formed the image database?
Yeah, good question. So I started, if you go to this Farfetch data set, which contains the original data set, you can see that it had all the brand name, the gender, the price, the image URL. So the only thing I did here was to take the image URL column and then use Fashion Clip to generate embeddings for those columns. So I didn't like create this data set from scratch, if that's what you're asking.
Good stuff. That makes sense. And then another related question from Arian, can we add to this data set manually? Is that something you did for this demo, or did you just use it as is?
Yeah, I just use it as is. It contained over 100,000 records, and to be honest, I only use 50,000 records. So you can definitely add to the data set. It was just not needed in my case. Oh, one caveat is I forgot to mention, it's kind of important, but this data set I found out after I built out the demo that it only contains women fashion. So if you want to, enrich a data set, maybe you can do that with like men fashion as well. But for now, if you upload a photo of like a tie or something, I doubt it's going to return anything relevant.
Good stuff. What about, there's been some questions about how were the embeddings developed? And I think I saw some earlier about, could you use one provider versus a different provider? I think I saw like, could you use an open source provider? But yeah, if you want to just talk about the embeddings again for a minute.
Yeah, so the one that I used today is called Fashion Clip, but I'm pretty sure you can use any open source embedding model that you find on Hugging Face, for example, that works with images. It's just I don't know how accurate it will be because Fashion Clip was trained on a fashion data set only. So I think the accuracy will be higher, but feel free to experiment with other models as well.
Good stuff. You don't happen to know the fashion clip tokenization limit off the top of your head, do you?
I do not know that, but I think if you can probably find that in your documentation.
Okay. Yeah, I'm Googling it right now, but I'll follow up with that question later on in the chat. Still a couple
Matt,
more questions still coming in. Oh, go ahead, Akmal.
sorry, Matt. I was just going to say that I don't know how related Fashion Clip is to just Clip from OpenAI, but I know in Clip, if you use something like a visual transformer, it's 512 or a 1024. I think that's the typically how many it will create in terms of the dimensions for the the vector embedding. And there's no tokenization limit in the sense that because you're not using an LLM to do it, but something else, which I'll secretly reveal tomorrow. Okay, top secret. So
We gotta keep some suspense here.
yes.
All right,
Actually,
so
a bit of a letdown.
I think my app has finally finished baking itself.
Yay.
So I was just trying to, upload the photo of the queen, and then I realized I didn't test the keyword part earlier. So say, with an image like this, the model doesn't know, like the app doesn't know if you want to match the coat or the bag or the gloves. So say I really just want to match the hat. So I can specify hat here, and then we're getting only the hat recommendations. And also, yeah, let's test out the price. So I definitely do not have like $900 for to buy a pink hat. So let's say my budget is like $500. So let's see if there is anything that can be found on Farfetch. And there we go. Yeah, I can probably buy this like pre-owned bucket hat for $250, but you can see that, yeah, we're combining the vector similarity search with a full text search as well as a price filtering. And that brings me to the end of the demo.
Awesome. I think we have time for one or two more questions before we wrap up and announce the raffle winner. I see one question from Ranjit. Does this data get replicated to transactional and analytical stores automatically?
Yeah, this is a great question. And I think this is a very common source of confusion. So we're just storing one copy of our data. You don't have a copy of your data in vector store, and then another in your like OLAP store, and then another in your OLTP store. So by default, when you create a table in SingleStore, you can query your data, and that's the same copy for data, whether you're doing like a transactional query or analytical query, or a vector search. We're working on that same copy of your data, and the table type supports any workload.
Awesome. I see another one from Brigand. Did you test this with and without the cutout embeddings for the query? If so, was the matching significantly better?
Yeah, that's another good question that I kind of left out in my explanation. So I tested with, remember how there's like both the model image and the cutout image. I tested with both, and I found that the cutout image was more accurate. That's why I left it in there, but that's a good question.
Good stuff. I'll choose maybe.
Oh,
yeah, that's a good. That's what I wanted to go ahead.
Oh, I was just going to say no duplicates.
No duplications of embeddings in the database. Is that what you were going to say?
Yep.
Okay, great. Good stuff. I think one more I thought I saw earlier, and Akmal, I know you've got experience with lots of different embeddings. I thought I saw some questions about the different types of embeddings and like the different models. Are these embeddings compatible between the different models? Do you need to stick to, once you've chosen an embeddings type, do you have to stick to that given incompatibilities? So Ingrid, I don't know if you want to talk to that, or Akmal, you're welcome to as well. I know you've had a lot of experience with different providers.
I'll just say quickly and then hand it to Ingrid. So yeah, there's lots of different models out there, lots of different limits in terms of tokenization, and depending on what you want to do. So as you saw, Ingrid chose a specific one for the problem at hand, simply because it's within the domain that she's looking at, and therefore it's customized for that particular problem space, which is great. I mean, someone else has done the hard work actually going through the effort of building that, and therefore it's much easier for you as a developer to take advantage of that. Some of these are very general purpose. Tomorrow, for example, when we look at Clip, I mean, it's general purpose. It's not confined specifically to fashion, so it can be used for a wide range of different images. And I'll be showing how we break down a video into frames and then get the embeddings from that, not using any OpenAI keys or anything like that, okay? So the technology is there. So lots of choices, many different ways to do it. And it's a good thing and a bad thing, because then you got to go to the trouble of evaluating the alternatives, finding what's best for you.
Awesome. I think that's a perfect segue into speaking of future sessions. As Akmal mentioned, tomorrow he's going to be doing building vector embeddings for video via Python notebook. I put the link to that in the chat. And then on Monday, we're doing fine-tuning your embeddings models with SingleStore. Then Tuesday, we're doing Apache Spark plus OpenAI for personalized banking services. It's going to be a busy few days for Akmal. Hopefully you see those links in the chat. You can RSVP, and hopefully we will see you at some of those future sessions. The announcement you've been waiting for, today's raffle winner is Manoj Kumar Gupta, the engineering manager at HelloFresh in Berlin. Congrats. Thanks for staying awake with us. If that's not you, don't give up. We're going to announce one more raffle winner by the end of the day to someone who has tried out today's demo. I'm going to put that link in the chat one more time. This will also be in your email. Everyone will get the recording the GitHub, the link to the Streamlit application, relevant resources. So keep an eye on your email. Maybe in the next hour or two, you'll get that. Thank you so much, Ingrid. This was an awesome presentation and demo. And thank you to our audience as well, and Akmal. Thanks, everyone.
Thanks,
Bye-bye.
everyone.